Okay, here we go. 2-2. Conditionals. Have your parents ever said to you, I'll let you go to that party on one condition?
Yeah.
And then they say, if you clean your room, you can go. Or if you this, then this, right? That's a conditional statement. It means if you do this thing first, then you can do this thing, right? That is a if-then statement, okay? A conditional is just an if-then statement. If this, then this. How you're going to see it a lot of the time when they like shorthand it, they use P and Q. P, well, let's just write this first. You say this, if P, then Q. Okay? P always represents the hypothesis of a statement, and Q always represents the conclusion of the statement. Okay? So think of this as the if portion. Okay? Whatever comes after if is your hypothesis. Whatever comes after then is your conclusion. Okay? Remember Venn diagrams? This is a Venn diagram of a conditional statement. It's saying if P, then Q, right? Basically, we're saying, for instance, if P was, if you're in Mrs. Verhoeven's class, okay, that's my P. My bigger thing is then you're taking a math class, right? Other people can take math classes. Other things can show up in that Q. But you're in that, if you're in Mrs. Verhoeven's, then you're in a math class, okay? So Verhoeven only teaches math, in other words. That's where you are. So let's go through a few examples of these, and then we'll chat about a few other things. Oh, by the way, for the homework, there's a lot of words in this homework. If you like to type and you're faster at typing, you may type the homework, okay? Because there are a lot of words, very few numbers in this section. Okay, example 1. It says, what are the hypothesis and the conclusion? Underline the hypothesis once, the conclusion twice. Okay, now here's the deal. If and then are not part of either of them, okay? Because if and then stay put, and sometimes we move the other parts. So I need to know what comes after the if is the hypothesis. So this would be an animal is a robin is your hypothesis. And it is a bird is the conclusion. Do not underline the if. Do not underline the then. Okay, they are not part of the hypothesis and conclusion. So if an animal is a robin, then it's a bird. Is that true? Yeah, if an animal is a robin, it is a bird. Is it true if we switch that? If an animal is a bird, then it's a robin? No. Interesting. Okay, letter B. If the sun is shining, then I'm going swimming. What is your hypothesis? The sun is shining. No if, right? Then I'm going swimming. What's your conclusion? I'm going swimming is my conclusion. Okay, no then. Any questions on hypothesis and conclusion? Okay. So sometimes they're going to ask you to write a conditional statement from a piece of information. So look at this letter A. It says vertical angles share a vertex. You have to turn that into an if-then statement. Anyone think they can do that? You'll add some words. Go for it. Bradley.
I was just completely brain fart. If it is a vertical angle, then it shares a vertex.
Yeah, so the hard part about this is coming up with like the subject that you're talking about, right? So we would say if two angles are vertical angles, right? Because vertical angles will always be 2. So if 2 angles are vertical angles, then they share a vertex. Oop. Oh, that's interesting. Does that make sense? If two angles are vertical angles, then they share a vertex. Okay. Letter B. Dolphins are mammals. How can you make that an if-then statement? Yeah, John.
If it's a dolphin, then it's a mammal.
Right. So again, the subject thing. What's it, right? If an animal, instead of calling it, that would be a more specific way. If an animal is a dolphin, then it's a mammal. Could you write that the other way? If an animal's a mammal, then it's a dolphin?
No.
Yeah.
Nope, doesn't work, right? So make sure what you're writing makes sense with what we're doing. Okay, so which is why I'm trying to show you that all of these things have a truth value. Basically, all of these statements are either true or false, right? They have a truth value. That's what I'm saying when I say truth value. What's their truth value? Is it true or is it false? So determine if it is true or false when they ask you to find the truth value, okay? Here's how this works. If your hypothesis is true, so whatever comes after if is true, and your conclusion is true, your conditional is true. But if the hypothesis is true and the conclusion part of it is false, then the conditional is going to be false. Okay? So basically, if I said, oh, what's a good one? Well, you know what? I'll show you on the examples. Never mind. We'll talk through the examples. Couple details though. You only need one counterexample to prove that a conditional is false. So if you can find any counterexample, the conditional is not true. Okay? And just remember that a counterexample is always going to make hypothesis true, conclusion false. This has to still be a true piece. Okay? Okay, so let's talk through these. True or false? And then if it's false, you always have to give a counterexample to prove that it's false. Okay? If a woman is Hungarian, then she is European. Do you guys know where Hungary is?
Yes.
In Europe.
It's in Europe. Yes. Okay, so if a woman is Hungarian, then she is European. True, because this and this are true, right? So that is a true statement. We can't find a counterexample. If a woman's Hungarian, she is going to be European, right? Okay, letter B. If a number is divisible by 3, then it's odd. False. This is false. This part has to be true now. So we're looking for a number that's divisible by 3 that is not odd. That's how you find a counterexample. What would that be? 12 is a great one. 6 is a great one, okay? You only need one, right? As soon as you find one counterexample, that statement is false, okay? So one counterexample and you're good. Questions on that? Okay, so just keep in mind, this is true, true. That makes it true. This is true, false. That makes it false, okay? Okay. Negation. A negation, what? I thought someone said something to me. No? Hearing things? A negation is the opposite. Like if you think negative, a negative number is the opposite of a positive number, right? So when you hear negation, think opposite, just like negative. It's the opposite of a statement. The symbol we use for it is the little tilde, a negation. So if I said the opposite of P, that would be I'm negating P, not P. Okay? An example. If I give you the statement, the sky is blue, and I say, write the negation of that. I'm saying, what's the opposite of that? So basically, you're not going to pick a different color because You can't say pink is the opposite of blue because not everyone's going to agree with that statement. You have to completely negate. So get rid of every other option. So if I'm saying the sky is blue, the negation would be, anybody? No, we can't pick another color. What word should I put right here?
Empty.
Not. The sky is not blue. That would be the opposite of the sky is blue, right? So when you negate, typically all it is adding that word in or taking that word out. Like if I said, the grass is not green, give me the negation, you would say what? The grass is green. Okay? So that's a negation. Okay, here it is. This chart right here is your best friend because these are the different types of statements that we're going to talk about. We're talking about conditional statements. Remember, conditionals are if-then statements. So these are all if-then statements. How it works is if I start with a conditional like this, if the measure of angle A equals 15, then angle A is acute. Okay, that's a conditional statement that we are going to symbolize as if P, then Q. Okay? The converse of that statement takes your P and Q, your hypothesis and conclusion, and flips them. So the converse takes your P and Q, right, and flips places. So instead of saying what we said here, if the measure of A is 15, then A is acute, we're going to flip it. If angle A is acute, then the measure of angle A is 15. Okay, so do you see that? We started with if P, then Q. We made it if Q, then P. You don't need to write this because it's right here, but I'm just showing you what is there. Okay, so conditional and it's converse. So if I said, if it's hot outside, then I'm going swimming. What would the converse of that be? If it's hot outside, then I'm going swimming. If I go swimming, then it's hot outside, right? I'm just switching where they are, okay? Okay, so that's converse. Inverse gets a little bit fancier. Inverse goes back to the original, but negates both parts. Remember, the little tilde means not, okay? So this is saying now instead of if the measure of A is 15, now we're saying if the measure of A does not equal 15, right? They negated it. Then A is not acute. If not P, then not Q. Okay? And then the last one takes the converse and the inverse and puts them together. So it switches them and it negates both. So this is if not Q, then not P. Okay? So if A is not acute, then A does not equal 15. Here's the deal. Any of these can be true or any of these can be false, but there is a relationship between some of them, okay? Here's what I want you to see. If the conditional is true, then the contrapositive is going to be true also. These will have the same truth value. So either it's going to be true conditional is true contrapositive, or a false conditional is going to be a false contrapositive, okay? Same goes for converse and inverse. These two have to have the same truth value. So if the converse is true, the inverse will be true. And if the inverse is true, the converse will be true. And vice versa. If the converse is false, the inverse will be false, okay? So it could be, let's do this. You have a lot of options here. I'm going to try to lay them out here and see if this makes sense to you. You could have a true conditional, which means you're going to have a true contrapositive, but the converse could be true, which means the inverse is going to be true. So it could be that all four statements are true, okay? It could be that the conditional and the contrapositive are true, but the converse and the inverse are false. So you could have that set up, Okay? It could be that the conditional is false, which means the contrapositive is going to be false, but the converse and inverse are both true. Anyone know the last combination that's possible? All false, right? These two are false, and these two are false. They're all false. So these are all the different combinations you can have, but you cannot go true, false, true, false. It won't happen. You cannot go false, true, false, true. It won't happen. And I always give them to you in this order, okay? So just keep in mind, the first and the last will have the same truth value. The middle two will have the same truth value. Okay, let's talk through this. You have this setup, okay? It says find the converse, inverse, and contrapositive of the problem below. And then we're going to determine what's true, what's false, okay? All right, so the conditional. If a figure is a square, here's your hypothesis, then the figure is a quadrilateral. First of all, is that true or false? That's true, right? If a figure is a square, it has to be a quadrilateral. It has to have 4 sides, okay? So my conditional is true. So which other one of those has to be true right now? The contrapositive, okay? But we don't even know what the contrapositive says, but we know it's true, okay? So you can circle that right away if you want, because if the conditional is true, the contrapositive will be true, okay? I want the converse of that statement. So the statement is, if a figure is a square, then it's a quadrilateral. What's the converse? Yes. Then the figure is a square. You just switch hypothesis and conclusion, right? So if a figure is, I do a lot of shorthand with this, by the way. I'm fine with you abbreviating things as long as it's very evident what that abbreviation is, okay? If a figure is a quadrilateral, then the figure is a square. Is that true? No. Can you give me a counterexample? A rectangle, right? A rectangle doesn't have to be a square. So a counterexample, I'll just write that here in case you want to refer back. A counterexample would be, a rectangle or a kite or any 4-sided figure that isn't a square, okay? Sorry, that still looks like an S. It's an R. Okay, so that's the converse. Now, we just said the converse is false. The conditional and the contrapositive are true. What's the inverse's truth value? False. It's going to be false, okay? And now here's the thing. The inverse just goes back to the original and does what to it? It negates it, right? You add the knots in or you take the knots out. So how would you say the inverse of that first conditional?
If a figure is not a square, and it's not a quadrilateral.
Yes, if a figure is not a square, then it's not a quadrilateral. Okay? And then the last one, the contrapositive, what would that be? Here's a way you can think of this. This is the converse of the inverse, right? So you take the one right above it and you just switch them, hypothesis and conclusion. So if a figure is what? Not a quadrilateral, then what? Then it's not a square. Okay. And again, if it's false, you should be able to find a counterexample. So if a figure is not a square, then it's not a quadrilateral. Another counterexample here would be a rectangle, right? You can use the same counterexample for both of those. Okay. How are we doing? Isn't this stuff fun? Do you love it as much as I do? I love it. I kind of want to give you one more just to talk through. We're not even going to write it out. I'm going to write the original though, just so we have the wording. Let's say if you don't use your free late, then you get extra credit. Okay, which is technically not fully true, but we're going to pretend it's true. We're going to pretend you turned every assignment in. Okay, if you don't use your free late, then you get extra credit. True statement. What would the converse of that be? If you get extra credit, you didn't use your free late. That's the converse, right? We just swapped them. Okay? What would the inverse be?
You don't get extra credit?
Right. If you use your free late, okay, so negate this. If you do use your free late, then you don't get extra credit, right? We're negating both parts. So then the contrapositive, if you don't get extra credit, then you did use your free late. Does that make sense? Swap it and negate it. Yep. Really, you're just swapping the one right before it. You're just taking the converse of the inverse. Any questions on that? Okay.